Hi and welcome to this video. Here I want to show you the UT-511 from UNI-T, an insulation measuring device. The aim is to determine insulation resistance and detect deviations that may indicate defects in an electrical circuit. If damage, faults or defects are detected at an early stage, serious consequences can be effectively prevented by targeted maintenance or repair. There are three slightly different models available from UNI-T: the UT-511, 512 and 513. In the specs you can see the main differences of the three available models. Only the UT-511 starts with 100 volts and the two others with 500 volts. The maximum and minimum resistance values you can measure depends on the different test voltages. Using 100 volt, you can measure resistances from 100 kilo ohm to 500 meg ohm. As the two other models don't have this low voltage, it's not possible to measure values below 1 meg ohm. Otherwise, the UT-511 can measure values only up to 10 gigaohm, while the others can measure up to 100 gigaohm. All models have different weights and different accessories. The tester comes in a nice case, including a very short manual, 3 test leads for different applications, and 8 batteries Type C. It's a heavy-duty device with a huge display. The UT-511 has only a connector for an optional power adapter. The two others have power adapters included and an additional USB port. There's one screw to open the battery compartment for 8 batteries. First, let's try some simple measurement before we come to the main application. For voltage measurement, you need the single red and black test lead. The specs say that the DC measurement range is from 30 up to 1000 volts. I use my adjustable power supply and turn it to 31 volts, which is the maximum output voltage. By pressing this button, you can initiate voltage measurement and decide between DC and AC. Now I switch on my power supply and the meter shows 31 volts. That corresponds to the output of my power supply. The specs says that the measuring range is from 30 to 1000 volt. By turning my power supply down to 5 volts, the meter shows 5 and 0 volts. That means that a bit more than 5 volts is the lowest voltage you can measure. To make sure, I adjusted a bit more than 6 volts and that's the result. Now I try to measure resistors. For that we need the other red test lead and press the LO button for low resistance. The first resistor is 10 kilo ohm, but that's too high for this mode. The specs say that the range is from 0 to 1 kilo ohm. Here's a 680 ohm resistor. Now this is a 1 kilo ohm and 0.33 ohm. Below 30 ohms you will hear an additional beep. Now let's come to the main application by pressing HO for initiating the insulation resistance measurement mode. With the emergency stop button, you can switch off the meter immediately or shut down the meter when it crashes or doesn't react anymore. Pressing clear will erase the memory, or by long pressing switches on and off the backlight of the display. Long pressing the test button will start the insulation measurement. You can save and load measured values. With the up and down arrows you can choose the measuring voltage from 100, 250, 500 and 1000 volts. I choose 100 volts for shorting the test leads, and long pressing the test button will provide 100 volt to the crocodile clamps. The bar graph will rise to a bit more than 100 meg ohm. A little flash sign will indicate that the measurement is in progress and that high voltage is provided to the crocodiles, so take care not to touch the leads. By shorting the leads, the meter will show 0 ohms. Now I take a common power cable to measure the insulation between the two lines. If it's good, the meter should show OL for overload. I choose the test voltage of 1000 volts and start the test. So the meter shows no resistance, that means the cable is good. In my stuff box I found a cable with a bad insulation. Okay, not alarming bad, but not really good. Again I choose 1000 volt, press the test button. The value is rising because of the polarization of the insulating material. Now we want to find out the polarization index Pi of this cable. In short, the polarization index is a value that tells us something about the quality of insulation. It depends on humidity, chemical contamination or mechanical damage, and of course aging of the insulation material. You can find a lot more information about this on the web. For the Pi measurement I choose again 1000 volt and set the first timer by pressing the time button to 1 minute. By pressing time again, you choose the second timer and set it to 10 minutes. That's the standard procedure for a Pi measurement. Press start to execute the operation. The display shows the time for timer 1. After 1 minute, timer 1 has finished and timer 2 starts. After 10 minutes, timer 2 stops and finished the measurement. The display shows the calculated Pi value of 1.45. By pressing arrow right, it shows the resistance value after 10 minutes, and another right press shows the value after 1 minute. This table shows the meaning of the Pi values. The Pi value is calculated by resistance value after 10 minutes divided by the value after 1 minute. Now let's check a transformer. The measurement will be between the winding and the core or ground. Make sure there is no painting on the core connection. The measurement should show no resistance. You can do this also with a motor or with a power line installation in your house, but make sure to disconnect any main power from all things you want to measure. Now I want to know the voltages the UT511 generates. So I connected my voltmeter to the crocodiles, set the instrument to 100 volt and see what happens. The UT511 shows the inner resistance of my multimeter with about 10 meg ohms, and the multimeter shows 106 volt from the UNI-T. Same with 500 volts and again with 1000 volts. Next, I want to measure a very high resistance. For that, I use a pencil making graphite stripes on a sheet of paper. Put the crocodile clamps on and see about 335 meg ohms. But I want to see a higher resistance. So again, some graphite, and here we reach the end of the resistance range, which is about 10 gigaohm. Last thing, I want to test my high voltage probe. I made this some time ago for measuring the laser tube in a K40 laser. It should show 101 meg ohm. Yes, perfect. I hope you find this video helpful. If you want to give me feedback, you can write in the comments or subscribe my channel. So long, see you next time.